Alright, today's notes are all about similar figures. Two figures are similar if and only if one is congruent to the image of the other by a dilation. So if we're looking at these figures and we want to know if they're similar or not, we have two squares, two equilateral triangles, and two rectangles. Two squares are always going to be similar because we can always find a scale factor from a side of the large one to the side of a small one. So all squares are similar. And the same goes for equilateral triangles. All equilateral triangles are similar. But if we look at these two rectangles, there's not just one scale factor that could keep the bottom sides the same, but change the left and right sides from the two shapes. So not all rectangles are similar. But some are. And that leads us to our next portion. And that is the polygon similarity postulate. Two polygons are similar if and only if there is a way of setting up a correspondence between their sides and angles such that the following conditions are met. Each pair of corresponding angles is congruent. Each pair of corresponding sides is proportional. So, if we're looking at our example to our right, we have two triangles and we need to know if they are similar or not. So the first thing that we can check is, are corresponding angles congruent? We know that angle D and A are congruent because they're both 100, but then we have these missing sides. Luckily, we know that a triangle always adds up to 180. So we take 180 minus 100 minus 33. In doing so, we get 47 degrees, which tells us our missing angle is congruent, and the small angles must be congruent as well. So, condition 1 checks off. Next, we need to see if each pair of corresponding sides is proportional. So, we look at longest sides, second longest sides, then smallest sides. So we would take 16.2 divided by 10.8, and we check to see if that's equal to all of our other sides. So we still have the other ones to check. Second longest sides, 12 divided by 8, and 9 divided by 6. Now if we look at all of these, 16.2 divided by 10.8, in doing so, we get 1.5. 12 divided by 8 also equals 1.5. And 9 divided by 6 is 1.5. In all of these, we get 1.5, and that proportion or fraction, that is our scale factor. And we know these two shapes are similar because all sides are proportional, we have a constant scale factor, and all three angles are the same. Now you're also going to be running into examples where we have variables in them. And it's going to ask us to solve for x. So we have the pair of triangles are similar. Solve for x. So we know that each corresponding side is proportional. So we know that BC is congruent to DE. So 3x plus 1 over x plus 2 is going to be equal to 8x over 12. So now this is where we need to get really good at solving proportions. So we cross multiply and we get 8x squared plus 16x equals 36x plus 12. Now we need to be able to solve this for x. Now, from last year, we should be recognizing that x squared as a quadratic. And we're going to need to use our quadratic formula. And our quadratic formula is this. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. This is assuming that we have a quadratic in the following form. ax squared plus bx plus c equals 0. What this means is we have to get all the numbers on the left-hand side and a 0 on the right-hand side, and we need to combine all like terms so that we just have 3 things being added. Now a, b, or c could be 0 and it'll still work. The important part is that all the x's are on the left side and the right side equals 0. So now we need to do that to our equation. We have x squared and 16x on this side, so let's bring over 3x plus 12. So we subtract 36x and subtract 12, so we get 8x squared plus 16x minus 36x minus 12. And we simplify by combining like terms. 16x minus 36x gives us 20x. So we have 8x squared plus 20x minus 12 equals 0. So we have a equals 8, b equals 20. Sorry, this is going to be a negative 20. So b is negative 20, and c is negative 12. So we plug all of these values into our quadratic equation. So we plug them all in. So we have negative 20 plus or minus the square root of negative 20 squared minus 4 times 8 times negative 12, all of that over 2 times 8. And then from here we work on simplifying. So we would have 20 plus or minus the square root of 400 minus 4 times 8 is 32. We can keep this negative 12 for now, all over 16. And then our next round of simplification, we want to combine these two. So we would have the square root of 400. A negative times a negative gives us a positive. And then 32 times 12 gives us 382. Sorry, that'll be 384, not 82. All over 16. We do another round of simplifying to get 20 plus or minus the square root of 424 over 16. And then for the square root of 424, so simplifying from here, negative times a negative gives us positive 20 plus or minus square root of 400 minus 4 times 8 is 32, and we keep this negative 12 around for now, all over 16. And then we're going to take care of this part on the inside. We have 20 plus or minus the square root of 400. Negative times the negative is a positive. And then 32 times 12 gives us 384. All over 16 still. So we have 20 plus or minus the square root of 784 over 16. When we take the square root of 784, we end up with 28. And now this plus or minus, that means we break it up. We have 20 plus 28 over 16 and 20 minus 28 over 16, which gives us 48 over 16, which equals 3, and 20 minus 28 over 16 is negative 8 over 16, or negative 1/2. And that gives us our possible values for x. Now if we plug those back in, if we take that negative 1/2 and plug it in for x here, we get a side length of negative 4, which just does not work. We can't have negative side lengths. So, our final answer is going to be x equals 3. So, you write that down, and we are done. If you would like, there is a link to chapter or number 6 in the homework worked. Otherwise, have a good day and see you tomorrow.